Number 8, the last one on the sheet. Okay, a student places a ball at the bottom of an inclined surface, then gives it a push up the incline. So let's say the actually started down here and pushed it. So there's pushing going on until it gets to that mark, the -2 mark, and then that's when the student stops pushing it and the ball just starts rolling up the incline under the influence of some gravity trying to pull it back. And so we're told that when the ball's position is at -2 meters, which is why I marked that as -2, its velocity is 1.5 meters per second. Notice it's positive, so I let to up incline be positive. And the ball's acceleration is -0.5 meters per second squared. And its position, its initial position, is at -2, so that's why I gave it -2 meters. Make a table of the ball's velocities at times t equals 0, 1, 2, 3, and 4, and then find the ball's positions at these times. Okay, well, to do that velocity part for A, I would use the equation final velocity equals initial velocity plus acceleration times time. So in this case, it's going to be the final velocity, which is what we're looking for, is equal to 1.5 plus -0.5 times t. So at every second, we're going to subtract out 0.5. So at time 0, the velocity is 1.5, and these are all meters per second. So if I write the units up in the top, and these will be meters, then I don't have to write them all the way through. So 1.5 at 0. 1 second later, it loses a half, so it'll be 1.0 meters per second. And then at 2 seconds, it will have lost another half, so that's 0.5. And at 3 seconds, it'll be 0. So it'll have stopped moving. So it takes 3 seconds for it to stop moving. And then at 4, subtract another half, it's at -0.5. So then it starts going backward down the incline. Okay, so now that's the answer to part A. Part B it says find the ball's positions at these times. So for B, I would use final position equals initial position plus initial velocity times time plus 1/2 the acceleration times time squared. So that would be the initial position is -2 meters plus 1.5 meters per second times t, and half of -0.5 would be -0.25 t squared. Let me rewrite this because it's kind of cramped. So x equals -2 meters plus 1.5 meters per second times t seconds minus 0.25 t squared. And the units for 0.25 is meters per second squared. Okay, so we have to plug in, well, at 0, we know if you plug in 0 for everything, you get -2, so that's -2 meters. And then when you plug in 1, well, you get -2 plus 1.5 minus 0.25, and that ends up being -0.75. So it's right here. No, right here. Yeah. So it's right here at time, wrong color. So this is where it is at 1 second. At 2 seconds, when you plug in all the numbers, you get 0, meaning it's at the 0 position. So at 2 seconds, it's right here. At 3 seconds, it will have gone as far as 0.25 meters. So it's as far as here, and that's as high as it goes because we know that it stops at that position. And then at time t equal 4 seconds, it's back to the 0 position. So that means that it will now have rolled back, so it's also at this same position at t equal 4 seconds. So it basically is pushed, and it starts here, and it's slowing down, slowing down. So you'll see each second it's traveling less distance because it's slowing down. And then it goes, so it's going a positive distance, and then a smaller positive distance, and an even smaller positive distance. It stops here, and then at time t equals 3, it has come to a stop, and then it actually comes back. So then the displacement from t equals 3 to t equals 4 is negative. So it goes back in the negative direction. And that takes care of that. Now, if you want to do this, if you have a graphing calculator, then you can do this like so. So, okay, let me write down the equations that I have. So my velocity is equal to my initial velocity plus the acceleration times time. So on the calculator, it has to be y and x. So that'll be y equals, now the initial velocity was 1.5 and minus 0.5 times x. So the y1, this is going to be y1, is going to be my velocity. So 1.5 minus 0.5x. So there you go. I don't know if you can see that or not. Yep. Next. So now, for the position, we had -2 plus 1.5 times t minus 0.25 t squared. So that becomes y2 for me, and I'm going to put it in y2, is equal to -2 plus 1.5x. I have to use x because that's what the calculator works with, minus 0.25x squared. So notice here under y2, I'm going to put in -2 plus 1.5x minus 0.25x squared. So there's the equation for the position function. Now, above window you see table set. So if we do second window, table set, the default, it automatically starts at 0, which my time is 0, that's good, and it increases by 1s. If it was like, find it for 0.5 seconds, then 1 second, then 1.5 seconds, then I would want to increase by halves, but there, that's what I get. And so when I do second graph, you see above graph is table, so second graph. And so my x's are really my t's, and so here y1 is my velocities, so you'll see my velocities are 1.5, 1, 0.5, and 0, and then -0.5, just like I wrote down before and found out. And my positions are -2, -0.75, 0, 0.25, and then 0. So you get straight from here, as long as you keep track of that y1 is your velocity and y2 is your position, you can get it straight from the calculator once you put in the appropriate equations.